sometimes using direct substitution actually leads you into trouble, especially if you're dealing with rational functions. So let's say that we want to find the limit as x approaches negative 3 of the function x squared plus x minus 6 divided by x plus 3. So in my solution, my very first step, as your first step should always be, is to see what happens if you actually try to do direct substitution. In the numerator, the limit as x approaches negative 3 of x squared plus x minus 6 is going to be 0. In the denominator, the limit as x approaches negative 3 of x plus 3 is also 0. So I end up with this form of 0 over 0, which is called an indeterminate form. It doesn't make any sense. It doesn't have any mathematical meaning. So what I can do to have some sense in this limit is I can apply the dividing out technique. And the dividing out technique is basically just factoring. So I'm going to rewrite the problem. Limit as x approaches negative 3 of x squared plus x minus 6 divided by x plus 3 equals, I'm going to write the limit statement again, but now I'm going to factor out the numerator, and I'm going to leave the denominator the same. Notice that I have the same term in the numerator and the denominator, so I can cancel them out, and I'm left with the limit as x approaches negative 3 of x minus 2, which if I do direct substitution will be negative 3 minus 2, negative 5. So the limit of the original is negative 5. The second technique is very useful if when you're trying to find the limit of a function, you have some square root term in the numerator or denominator, like this. The limit as x approaches 0 of the square root x plus 1 minus 1 over x. Again, always try and see if direct substitution is going to work. In this case, the limit as x approaches 0 of the numerator gives me 0. The limit of the denominator also gives me 0. So once again, I end up with 0 over 0, which is an indeterminate form. What I can do is use this idea of a conjugate. And a conjugate, let's say you have a plus b. The conjugate of a plus b would be a minus b. So the a and the b stay the same. The only thing that changes is the sign. So the square root of x plus 1 minus 1 over x. I'm going to multiply by the conjugate of the numerator. Notice that I'm not really changing the function. I'm just multiplying it by 1. But when I do that, in the numerator, the square root goes away, and I end up with x plus 1 minus 1. And then in the denominator, I'm just going to put things together. Don't worry about combining anything. Just leave it like that. Because notice that in the numerator, 1 minus 1 cancel each other out. I'm left with an x in the numerator. And notice that there's an x in the denominator, so they cancel each other out. And I'm left with this form, 1 over the square root of x plus 1 plus 1. So let's go back to the original limit. Limit as x approaches 0 of the square root of x plus 1 minus 1 over x. It's going to equal the limit as x approaches 0 of this new form that we discovered, 1 over x plus 1, which when I apply direct substitution, I end up with 1/2. So the limit is 1/2.